And here's our first lesson on physics. So in physics, there are different branches in classical physics that we're going to be learning in regular physics classroom. And there's going to be mechanics. In mechanics is the study of motion and the cause of the motion. And we're going to be learning thermodynamics, the heat transfer, and the specific conductivity of the objects. We're not learning fluid mechanics in regular physics classroom. We will do some waves, not optics, and we will do electricity and magnetism in our classroom. And then in mechanics, you have two sub-branches, which is kinematics and dynamics. So kinematics is the study of the motion, like a cinema. They have the same root, cinema. So it's all about the motion, velocity, acceleration, distance, how long it takes. And dynamics is going to be all of the causes of the motion, why the objects are moving, and what causes the objects to move, how do they accelerate, what causes them to accelerate. So we're going to be starting today with kinematics. So in kinematics, you will see some formulas, and in dynamics, you will see different formulas. And I'm going to go over them. You don't have to memorize, but these are the formulas that you will have to know. So these are the kinematics formulas that we will be using all the way through the kinematics, and we're going to derive the new ones based on these formulas. So we did talk about displacement and distance and the differences between them in the previous video, and the link is in the description of this video. If you did not watch that video, you should watch that video. And so the two things, the difference between the average speed and average velocity. So the speed is only the part that doesn't have the direction. It's scalar. And the speed is the one that you can see on your speedometer. So speedometer shows you the speed. It doesn't tell you what direction you're driving. But velocity has a direction. So the average speed has a formula, and it is the distance, the total distance traveled over the time it took to travel. So if you look at the girl in the image on the right, you see that she traveled 3 meters, 3 meters, 2 meters, 1 meter, 2 meter, and 1 meter. So the total is 12 meters, and it took her 12 minutes. So the average speed for her movement, so I'm going to say the average speed, and average is going to be the line on the top. That means average. So if you see a line on the top of the letter, that means average. So the average speed is the total distance that she traveled. So the total distance that she traveled is 12 meters. And the time it took is 12 minutes. So the time it took is 12 minutes. So you could say that she is traveling 1 meter per minute. And the distance is going to be measured in meters, not in miles. And meter is the distance probably from your shoulder to the end of your fingers on the other arm, on the opposite arm. So if you took the distance from the shoulder, from one shoulder to the other arm, that will be to the end of the other arm. That will be the distance of 1 meter, or it's about 3 feet. So, but usually the velocity and speed measured in meters per second. So they have their measurements, meters per second. So I have to make sure that I have to convert my number that I just found into meters per second. So instead of minutes in my denominator, I'm gonna plug in seconds. So I got 1 meter per minute, but I'm gonna plug in 60 seconds because that's what it is, 1 minute. So I get 1 over 60 meters per second. So that's how much she is moving each second. So that is her average speed, but that is not her average velocity. So her average velocity is her displacement over the time it took her to travel. So if it took her to travel 12 meters, that was her total distance traveled. So if I wanted to find average speed, I would take her distance, divide by the time, and that will give me her average speed. But if I want to find her average velocity, so for the velocity, I'm going to use the letter V. average means the letter the line on the top, and that is the displacement over time. And if you see from the graph, from the image, her displacement is 3 meters. So this part is the displacement. And again, if you are confused with displacement and the distances, watch the previous videos. So here I have her displacement is 3 meters, and it took her 12 minutes. In other words, I have 1/4 minutes, or 1 meter. Yes, it's the distance of 1 meter. 1 meter over 4 minutes. And because it has to be measured in meters per second, I can simplify it as 1 meter per 4 times 60 seconds. So 1/240 meters per second. So wherever that number is. So here's the difference between average speed and average velocity and how to calculate it. So speed and velocity is going to be measured in meters per second. It is distance over time for average speed, and it is displacement over time for the average velocity. So we just looked at average velocity formula. It's the displacement over time. In physics, often our displacement and distance is the same thing. If an object is moving in the same direction without turning back, its distance and displacement is going to be the same thing. So sometimes you will hear me saying distance over time, but you have to remember, so for average velocity we use displacement over time, and it's only the same thing when it drives in the same direction. So that was our average velocity, and it is the displacement over time, so there should be a line on the top. This is average velocity. And then for acceleration, you can pause it and think about what acceleration is before I give it away to you. But if you already paused it and thought about it, or decided not to think and hear what I'm going to say about the acceleration is the change of the velocity over the time. So the formula here we're going to be using is the change of the velocity over the time. Your average velocity is measured in meters per second, and acceleration is going to be measured in meters per second squared. So what does it mean acceleration is in meters per second squared, and what is acceleration? So acceleration is equal to the change, so the triangle right here means change of the velocity over time. And what does it mean, change? So if you came into the room and you had $5 in your pocket, and by the time you're leaving you have $7 in your pocket, so there is a change in your pocket. But how much by how much is the change? So you would think you have 7, you used to have 5, so the change is 2. So if you're looking for the change of the velocity, it's always going to be the final velocity minus the initial velocity over the time. So if you see the triangle, that means change. Sometimes they call it delta for the triangle. So it's a change, and it's the final over minus initial over the time. And because the final minus initial is measured in meters per second, and the time is measured per seconds, this is where you get meters per second each second. So the acceleration is going to be showing by how many meters per second your velocity changes each second. So if your initial velocity, let's say sub-zero means initial velocity, is 2 meters per second, and your acceleration is 3 meters per second each second, so I'm going to say squared, what is going to be your final velocity? This line will mean in 4 seconds. So if I start with 2 meters per second, in 4 seconds, in 1 second, I'm going to have 5. In 2 seconds, I'm going to have plus 3, right? 8. In 3 seconds, I'm going to have 11 meters per second. In 4 seconds, I'm going to have 14 meters per second. So that's going to be 14 meters per second. So my final velocity in 4 seconds is going to be 14 meters per second. I didn't give you the formula for it, and I will not give you a formula for final velocity, but I want you to understand that your final velocity depends on what your acceleration is and your initial velocity and how long it takes to change that velocity. So how I calculated is this. The final velocity was, I took the initial velocity and then I added acceleration as many seconds as I told you. So my initial velocity was 2, and I said the acceleration was 3, and the time I took 4 seconds. So my final velocity became 14 meters per second. So my acceleration is the indicator by how much velocity changes each second. That's why it is meters per second squared. Let's look at some questions that you have in your lessons online. What would be the final velocity of an object if the distance it traveled, or displacement if it's in the same direction and the distance the same thing, if its initial velocity was 4 meters per second and its acceleration is 2 meters per second squared for 5 seconds. In these questions, I'm always going to start with wherever is given. So I'm going to say initial velocity of an object was 4 meters per second. The acceleration is given. So the acceleration is 2 meters per second squared. Acceleration is 2 meters per second squared. The time is given 5 seconds. So I always have to write everything that is given. Now I'm going to write the formulas that I need to use. So they told me to find final velocity, and they've told me to find the distance. So far, this is what I know. I know average velocity is equal to the displacement over time. I can say distance over time if it's in the same direction. And acceleration is equal to change of the velocity over the time. I also learned that the final velocity is equal to initial velocity plus acceleration times the time. So far, I just saw these formulas, and I can try to use these formulas to solve my question. So at first I need to find final velocity. I'm going to look at what is given in final velocity. Do I have initial velocity? I do. Do I have acceleration? I do. Do I have a time? I do. So to find final velocity, I'm going to plug in initial velocity plus the acceleration times the time. So the final velocity is equal to initial velocity plus acceleration times the time, gives me 14 meters per second. Now I have to find the distance. So the distance is given by average velocity is equal to distance over time. So I can rewrite this formula differently. I can write this formula as the distance is equal to average velocity times the time. And there is one more way to find average velocity that I didn't tell you yet, but it is the average between two velocities that you know. You know initial velocity, you know the final velocity. So the average is its initial plus the final divided by 2. The average between two numbers is their sum divided by 2. So I have initial velocity plus the final velocity divided by 2 times the time. So here is another formula that you also should know. And we're going to use it so many times that you have no choice, you will know. So the distance is equal to average velocity, so initial, plus the final, divided by 2 times the time, which is 5 seconds. So I get 18 over 2, which is 9, times 5 gives me 45 meters. Let's look at one more question and pause it and try to solve it on your own before I solve it, and I'm going to show you the work afterwards. So here again, I'm starting with everything that is given. So initial velocity is given, acceleration is given, and time is given. Then I'm writing down the formulas that I need to use. I rewrote my average velocity formula as the distance formula, or the displacement, which is average velocity times the time. And now I'm going to find the final velocity first. So the final velocity depends on what the initial velocity was plus the acceleration times the time. If I plug in my numbers, I have 6 plus 2 times 4, which is 14 meters per second. Then if I want to find the displacement or distance, I need average velocity times the time. Average means initial plus the final, divide by 2, and times the time. So again, I need to remember that average is going to be the sum of two velocities divided by 2. So if I have initial and the final, to find average between them, I add them, divide by 2. So the displacement or distance in this case is equal to initial velocity plus the final velocity divided by 2, and time is 4 seconds. So I have 20 divided by 2, so that gives me 40 meters. Here is the next question. Again, pause it. Try to solve it yourself first based on the formulas. Always write the formulas in your notes somewhere so you don't have to go back to the video and find the formulas or use the notes. So pause it, try to solve it first, and then watch me solving the problem. And as always, I start with everything that is given, and then after what's given, I'm gonna use the formulas, write the formulas that I know and I should know, and then I'm gonna use this formula to these formulas to figure out what they ask me. So the first they say, what's the object's acceleration? So I am gonna use the acceleration formula to find acceleration. So acceleration is equal to change of the velocity over the time. And this is a common mistake that students make when they just start physics. What is the change? What does this triangle mean? I just told you earlier, do you remember what that change means? So is it initial plus the final divided by 2? Or is it the final minus initial? So change means the final velocity minus initial velocity, and then over the time. Your final velocity is 23 and your initial velocity is 3, and the time is given is 10. So acceleration is equal to 2 meters per second squared. Second part, they ask you what is the distance that the object traveled. So if I need to find the distance, it is average velocity times the time. And again, I need to remember what the average means. Average means its initial velocity plus the final velocity. It's the sum of the velocities divided by 2 times the time. So the distance or the displacement equal to initial velocity plus the final velocity divided by 2, which is 26 divided by 2, gives me times the time. And the time is 10 seconds. So I'm going to say times 10. So I have 26 divided by 2, 13, and 13 times 10 will give me 130 meters. Here is number 6, and again, pause it, try to solve it before I'm not going to solve this question, I'm just going to give you the answers, and if you mess it up or don't get the same answer, just watch number 5 one more time and see if you can figure it out. So pause it and try to solve it. And if you solved it, then you should get the answer as 4 meters per second squared for acceleration, and the distance or displacement traveled 84 meters. Here's a new type of question, and I'm going to write down everything that is given. As always, I want you to write down as well. And then after you write down, pause it, write down everything that is given, write all the formulas that you know, and let's think how to solve this question. So the information that is given, the total time that the group of bikers traveled is 4 hours. They traveled over the first 3 hours, they traveled 50 kilometers, and over the last hour, they traveled 10 kilometers. They ask you to find average speed. So if you remember that the average speed is equal to the distance traveled over the time. So the distance traveled here is 60 kilometers, and it's in the same direction, so I don't have to worry about even if it was in the same direction. So here it is 60 kilometers, and in the time it took, the total time is 4 hours. So the total speed, and in this case I'm not gonna convert it into meters per second, gives me 15 kilometers an hour. I could ask you not average speed, I could ask you average velocity. And in this case, because it is in the same direction, your average velocity is the same as average speed. Here's another question that is very similar to the one that we just did. Now, suppose the car travels 90 meters due north in 15 seconds and then turns around and travels 40 meters due south in 5 seconds. Find the average speed of the car during this 20-second interval, or average velocity during this 20-second interval. Again, pause it, try to solve it, write the formulas, write everything that is given, and then come back and then let's try to solve it together. So I wrote everything that is given. The total distance is, we have 90 meters in one direction and then 40 meters in the opposite direction, but the distance is 130 meters. Displacement is 50 meters because it went 90 meters in this direction and then 40 meters back. So the displacement is going to be how far from the point where it started. So the displacement in this case is 50 meters. So I have the average speed, which is the total distance over the time. The total distance is 130 and the time is 20 seconds. That gives me 6.5 meters per second for the average speed. For the average velocity, I have the displacement. So displacement is 50 and the time is 20 seconds. So that gives me 2.5 meters per second. Here's the new type of a question. And again, let's write everything that is given. And then after you write everything that is given, pause it, try to solve it, and then watch me solving the question. So I wrote this way. I see 400 kilometers at 80 kilometers an hour and then 400 kilometers at 100 kilometers an hour, and it was in the same direction. So from, let's see, if I need to find average speed, I need the total distance over the time, and if I need average velocity, I need the displacement over the time. And because it's in the same direction, my average speed and my average velocity would be the same thing. But I need to find the time. So if an object travels 400 kilometers at 80 kilometers an hour, that means every hour it travels 80 kilometers. So in 1 hour it covers 80 kilometers, in 2 hours it covers 160 kilometers, and so on. So I know that the distance is equal to average velocity times the time. And so if I want to find the time, it is the distance over the average velocity. And because they say the velocity doesn't change for the object for the first 400 kilometers, the distance is 400 kilometers and the velocity is 80 kilometers an hour. So that gives me an answer in hours, which is 5 hours. So I know the first distance, it took 5 hours for the motorists to travel, so that is 5 hours. And then for the second, he travels 100 kilometers each hour, so that one is 4 hours. So if I am looking for the average speed, I need the total distance, which is 800 kilometers, and the time it took, and that is 9 hours. So that gives me an answer of 89 kilometers an hour. Let's check this one out. So in this case, I have 320 kilometers at the velocity of 80 kilometers an hour. And then the second one is 80 kilometers. My drawing is not to scale. At 40 kilometers an hour. So from here I see it would take 4 hours. And then from here it would take 2 hours. And they ask you to find average velocity. Oh, and it's in opposite direction. It's in opposite direction. So the average velocity is the displacement. So if they move 320 kilometers and then 80 kilometers back, the displacement is 240 kilometers, and the time total took is 6 hours. So the average velocity is 40 kilometers an hour. I skip a few questions. I think those are easy to solve, but I want to do one of the questions that you might need help with. So it takes 6 seconds. So I'm going to write again everything that is given. Time is 6 seconds. For an object to traveling at 48 meters per second to stop. So if an object is traveling with this velocity and is going to stop, then this velocity is initial velocity. And to stop means the final velocity is 0 meters per second. So how far did it travel over the time it was decelerating? And what is the deceleration? And how far means the distance or the displacement. And that is the average velocity times the time. And again, the average, don't mess it up with change of the velocity. Average means initial plus the final. Initial plus the final over 2. Initial plus the final divided by 2 times 6 seconds. So the distance is equal to, or the displacement is equal to 144 meters. And then what is the acceleration or deceleration? So the acceleration is equal to change of the velocity over the time. And this is the one that I have to remember, that the change of the velocity is the final minus initial. Your final is 0. Your initial is 48 meters per second. And the time it took 6 seconds. So that gives you negative 8 meters per second squared. And acceleration is a vector, so it has a direction. And because it has a direction, it can be a positive or a negative. So if I choose velocity to be positive, but the velocity is getting smaller and smaller, that means you have acceleration in the opposite direction. And if the acceleration in the opposite direction, then that one is becoming negative. Here is a tricky question, but it's pretty easy. They give you initial velocity and they give you final velocity, and they ask you to find average velocity, and they also give you time. So if they ask you acceleration, you know for acceleration you need the change of the velocity over the time. So your final velocity is 38, your initial velocity is 12, the time took 4 seconds. You can find your acceleration. But they didn't ask you acceleration, they asked you average velocity. But for average velocity, the distance is equal to average velocity times the time. You need the distance, but you don't have the distance. But you always have to remember that sometimes you can use this. Average velocity is initial plus the final divided by 2. You don't even have to use the time that they give you. So if you want to find average velocity in this case, you have initial velocity plus the final velocity divided by 2. So that gives you 50 divided by 2 gives you 25 meters per second. And if they ask you to find the distance, then you could do the distance is equal to average velocity, which is 25, times the time, which is 4 seconds, would give you 100 meters. But none of these were asked to find, so you didn't need acceleration, you didn't need the distance. All you needed is average velocity, and they gave you initial and the final. So you could use average velocity trick formula to find your average velocity that they ask about.